guys have an idea what engineering survey is? No? It's okay, that's the reason me and my friends here today to educate you guys. So what exactly is engineering survey? Engineering survey is a specialized type of surveying that provides accurate measurement and data needed for the planning, design, construction, and even the maintenance of engineering projects. But in simple words, surveying is basically the art of measuring distance, angles, and position on or near the surface of the earth. Even dictionary defines surveying as the measuring and recording of the details of an area of land, which includes things like boundaries, size, position, quantity, condition, and even value. Pretty cool, right? So how does surveying actually help engineers? Well, there's a huge role. Here's how. It determines the shape, size, and elevation of the land. It helps engineers design roads, buildings, bridges, railways, and many more structures. It sets out the exact location where each part of a project needs to be built. It monitors movement or deformation in structures like dams and towers, and most importantly, it ensures everything is built according to the plan. Without proper surveying, engineers would basically be building blind. And finally, who's the hero doing all this important work? It's the surveyor, the person trained to measure, analyze, and interpret the land. Surveyors are like the eyes of an engineering project. Alright, so moving on, let's talk about something super important in surveying. It is leveling. So what is leveling? Leveling is basically one of the methods we use to determine the heights of different points on the ground. Of course, today we also have fancy tools like total station, handheld laser distance meter, and GNSS receivers to measure height. But leveling remains a favorite on construction sites because it is simple, accurate, versatile, and affordable. That's why even with all the modern technology, leveling is still the OG method we trust. To perform leveling, we use a few basic instruments including tripod, leveling staff, staff bubbles, and automatic level. After this, my friend Adriana will show you how this instrument looks like in real life. There is a basic principles of leveling that we follow. At its core, the idea is simple. We measure height difference between points, usually along a straight line, and we calculate the heights using one of two methods. Number one is rise and fall method. Number two is height of collimation HOC or height of plane of collimation HPC method. Both do the same thing actually, but just different styles of calculation. And there is a basic rules for leveling. To get accurate results, we follow a few important rules. To start and finish at points with known heights, this could be a benchmark, temporary benchmark, or a loop. To keep the distance between the staff and instrument under 30 meters and even closer if the slope is steep. To hold the staff vertically, use the staff bubble to make sure it's straight. Keep backside and foresight distance roughly equal because this can help reduce errors. Even though leveling is simple, mistakes can happen. Common errors include the line of collimation is not perfectly horizontal, the staff is imperfect or damaged, the staff is not held vertically, the instrument is not leveled properly, heat wave from the environment distort reading, lastly the staff is placed on soft or unstable ground. This small error can cause a big problem, so surveyor must stay alert. Why is leveling important? Number one is to determine accurate height. We need precise elevation values to design safe and stable structures. Number two, to ensure structures are built correctly. Roads, bridges, drains, and buildings all depends on correct levels. If the levels are wrong, the whole structure can fail. Number three, to prepare construction sites. Before construction starts, leveling shows how much soil needs to be cut or filled. And number four, to create accurate maps. Leveling helps produce contour maps, which are essential for planning. And number five, to ensure safety. Proper leveling prevents uneven foundation, water logging, weak roads, structural failures. Basically, leveling keeps everything safe, stable, and built exactly as planned. And that is leveling. A simple method, powerful results, and one of the most important skills in surveying. Thank you for listening, and I will pass to my friend. Bye!
So right now, we will show you guys on how to set up the leveling equipment. First, open and spread the tripod leg on the ground. Second, press the feet of the tripod down in the ground to make sure it doesn't move. Third, put the automatic level on the tripod head and attach it with the tripod screw. Fourth, adjust the tripod leg until the pond bubble is centralized. Fifth, the leveling staff must be held vertically using the staff bubble that is attached to it to ensure the bubble is centered. And lastly, take the readings measurement and record the data in the level book throughout the survey.
First and foremost, position the staff at the first point, which is datum. Hold the staff vertically using the staff bubble. Take the back side reading. Then, take intermediate side IS readings. Move the staff to intermediate points. Take readings without moving the instrument. This point helps capture the ground profile. After that, move the staff to the next change point. Place the staff at a new location where height change is needed. Take the foresight FS reading. Then, move the instrument. After taking the FS, shift the outer level to a new position, level it again, and take a new backside on the same change point to continue the leveling loop. Repeat BS, IS, FS process until all stations are covered. Continue taking the BS, IS, and FS readings. Calculate rise and fall. Compute reduced level. Continue until final point.
Hi everyone, today I'm going to show you how to calculate rise and fall in leveling, including both the initial reduced levels and the adjusted reduced levels to make sure our survey is accurate and balanced. First, a few quick terms. BS or backside is the reading on a point with a known elevation. IS or intermediate side is a reading on point in between. FS or foresight is a reading on a point we want to determine the elevation of. The initial reduced level is what we calculate directly from our reading, while the adjusted reduced level is what we get after we correct for any closing error. We start by setting up our level and recording all the readings along with the datum reduced level at our starting point. For each consecutive point, we compare the current reading with the previous one. If the previous reading is larger, it is a fall, and if it is smaller, it's a rise. We record each rise and fall, then calculate the initial reduced level for each point in order, adding the rise or subtracting the fall from the previous reduced level. Once we reach the last point, we compare the last initial reduced level with the known reduced level to find the closing error, which tells us how far off our survey is. We then distribute this error evenly along the line and adjust each initial reduced level accordingly to get the final adjusted reduced level. In the end, we have a complete table showing BS, IS, FS, rise, fall, initial reduced level, and adjusted reduced level, giving us a clear and accurate picture of the elevation along the survey line. Remember to double check each reading and calculation as you go to make sure everything is reliable.
In summary, our leveling project went smoothly and was completed successfully. We collected and processed all the field data using the rise and fall method, and every calculation passed the arithmetic checks. Our final disclosure was 0.004 meters, which is within the acceptable tolerance, so our results are accurate and reliable. This project achieved three main goals. The first one is determining reduced levels, or else. we managed to find the elevation or RL for every point we surveyed. This gives us the vertical information needed for future site work. The second one is setting up the temporary benchmark, TBM. We transferred the known elevation to establish a new TBM at Mahala Aminah Skat House. This TBM can now be used as a reference point for upcoming construction activities. The last one is ensuring precision and accuracy. By following proper field procedures and double-checking our calculations, we confirm that the survey meets the required engineering standards.